Hi friends, how are you? This is Prant Reddy studying 10th standard. Today in this session we are going to learn briefly about heat chapter from physics subject. Okay, let's get start our session. Okay, now we get into our session about heat. And what is heat? Heat is a form of energy that flows from hotter body to colder body. Right? Heat is the form of energy that flows from hotter body to colder body. Or we say like this also, heat is the form of energy that it transit from the body at higher temperature to body at lower temperature. It is said to be also heat. The SI unit of heat is joule, represented in capital J. The CGS unit of heat is calorie. It represented in CAL, capital C, small al. The SI unit is joule and the CGS unit is calorie. This is about heat. And what is calorie? Calorie means the amount of heat energy required to rise the temperature of 1 gram of water by 1 degree Celsius is said to be calorie. It means when we take 1 gram of water, it will be rise the temperature by 1 degree Celsius. It is said to be calorie. Right? 1 calorie is equal to 4.186 joules. We said no, the calorie is CGS unit of heat and the joule is SI unit of heat. 1 calorie is equal to 4.186 joules. Right? Next, what is thermal equilibrium? When two bodies are in thermal contact, the heat energy transmit from higher temperature body to lower temperature body. This is known as thermal equilibrium. I will repeat once again. When two bodies are set in the thermal contact, the heat energy transmit from body at higher temperature to body at lower temperature. This is thermal equilibrium. Right? Next, the state of thermal equilibrium denotes the state of body where it neither receives nor gives out a heat energy. Meaning of this sentence is, if two bodies are getting into thermal contact, one is the hot body and one is the colder body. This thermal equilibrium says which is the hotter body that lost the energy, which is the cold body that gains the energy. Right? This body lost the energy, this body gains the energy from this heat body. Right? This is said to be in the thermal equilibrium. Right? Next, what is temperature? Temperature is a degree of hotness or coldness. It is said to be temperature. Temperature is the degree of hotness or coldness. Temperature is a measure of thermal equilibrium. Right? Temperature is a measure of thermal equilibrium. And the SI unit of temperature is Kelvin. K. The temperature unit of SI unit of temperature is Kelvin. It represented in capital K. And the CGS unit of temperature is degree Celsius. Right? Degree Celsius. And 0 degree Celsius is equal to 273 Kelvin. We got so many problems on this formula. Right? 0 degree Celsius is equal to 273 Kelvin. Right? When here 10 degrees Celsius is equal to, change it into Kelvin scale. Right? This is the question in 1 mark or 2 marks. Change 10 degrees Celsius into Kelvin scale. Then we add 273 to the 10 degrees Celsius. 273 plus 10 is equal to 283. 10 degrees Celsius is equal to 283 Kelvin. This is the right. Next, they given 20 degrees Celsius. Change it into Kelvin scale. It means 273 plus 20 degrees Celsius. 273 plus 20. 293 degree Celsius. Right? If they given that Kelvin scale they given, change it into Celsius scale. Okay? Then they given 283 Kelvin. Then change it into Celsius scale. Right now we subtract 273 Kelvin from 283. Right, 283 minus 273, 10 degrees Celsius. Then 283 degree Kelvin is equal to 10 degrees Celsius. Right, this like the questions are come in the exams. For 1 mark or 2 marks they will ask these questions. Right, next, what is absolute temperature? Right, what is absolute temperature? Temperature measured in Kelvin scale is called absolute temperature. The temperature which is measured on Kelvin scale is called absolute temperature. This is absolute temperature. The next, specific heat. This is important. The specific heat. Specific heat of a substance is the amount of heat energy required to rise the temperature of unit mass of the substance. Right? Specific heat of a substance is the amount of heat energy required to rise the temperature of unit mass of the substance. Specific unit means the heat energy required to rise the temperature of unit mass of the substance. It is said to be specific heat. The rate of rise in temperature depends on the nature of the substance. Right now, the rate of rise in temperature depends on the nature of the substance. Right? Okay. What is the specific heat formula? The specific heat formula is heat energy by mass into change in temperature. It means Q by M into delta T. Right? And the unit of specific heat in CGS is calorie per grams per degree Celsius. Calorie by grams per degree Celsius. And the SI unit of this specific heat is joule by kg per Kelvin. Right? And the CGS unit is calorie by grams per degree Celsius, and SI unit is joule per kg per Kelvin. Joule by kg per Kelvin. The specific heat of water is 1 into calorie by grams per degree Celsius. This is the specific heat of water. Right. Next, the applications of specific heat. What are the applications of specific heat? When we see that when a watermelon brought from the refrigerator retains its coolness for a longer time because it contains large amount of water than any fruits. The water have high specific heat, so it retains long time as cool. Right, watermelon brought from the refrigerator retains its coolness for a longer time because it contains large amount of water which has high specific heat. Next, when we see a samosa appears to be cool outside, but the curry inside the samosa is in hotness because its specific heat is high, so that the curry is hot in that samosa. Right, next, water takes much time to become hot and also taken much time to become cool due to high specific heat value. In the chapter, in the textbook, they had given the substances and their specific heat units. We have to learn that table. That is an important table in this lesson, right? Next, method of mixtures. The principle of method of mixtures. What is the principle of method of mixtures? Heat lost by the hotter body is equal to heat gained by the colder body. It is the principle of method of mixtures. Net heat lost is equal to net heat gain. Right? Next, what is evaporation? This is very important. In essay 1 exam, they asked the differences between the evaporation and boiling. Right? The differences between the evaporation and boiling. Right? Evaporation, the process of escaping of molecules from the surface of a liquid at any temperature is called evaporation. The process of escaping molecules from the surface of liquid at any temperature is said to be evaporation. This evaporation is a cooling process. This evaporation is a cooling process. For example, wet cloths dries. This is also form of evaporation. In evaporation depends on its surface area, temperature, and amount of humidity present in air, already present in surrounding air. It depends on these factors. The evaporation depends on surface area, the temperature, and amount of water vapor already present in the air. It is also called humidity, right? Next, condensation. The phase changes from gas to liquid is called condensation. The phase change from gas to liquid is called condensation. Condensation is a heating process, is also known as warming process. Condensation is a warming process. It is reverse process of evaporation, right? Evaporation, it means escaping of molecules from surface of the liquid at any temperature, right? This is the phase which from gaseous to liquid, the phase which is changes from gaseous to liquid, it is called condensation. This is the reverse process of evaporation. For example, water vapor in air condenses when we keep the chilled drink bottle in the air. It means cool drinking bottle in the air. Around the outside of the bottle, the water droplets are formed. This is due to of condensation, right? This is the example for condensation. Next, humidity. The amount of water vapor present in air is called humidity. The amount of water vapor present in the air is called humidity, right? Next, dew. What is dew? The water droplets condensed on various surfaces are known as dew. The water droplets condensed on various surfaces are known as dew. Are also said to be the water droplets which is condensed on window panes, bikes, etc. in the morning. It is said to be dew, right? Dew forms due to condensation during winter season. It mostly forms in winter season due to condensation process. The water droplets which condensed on objects in the early morning in winter season is said to be dew, right? Dew forms due to condensation. It's important. Next, fog. What is fog? The water droplets condensed in the dust particles in the air keep floating in the air is called fog. The water droplets condensed on the dust particles in air keep floating in the air is said to be fog. This fog also formed due to condensation process during winter seasons or cooling days, right? Mostly this fog or dew are formed in winter seasons due to condensation. We have to remember compulsory this dew and fog. Some members think that is dew and fog is same, but not. The dew is the water droplets condensed on the surfaces, right? The fog is water droplets condensed on dust particles in the air. Then it is floating in the air. This is called fog. This is the differences between dew and fog. Next, boiling. Boil. What is boiling? Boiling is a process in which the liquid phase changes to gaseous phase at constant temperature at a given pressure. It is somewhat related to evaporation, but evaporation is at any temperature. Boiling is at constant temperature. Boiling is the process in which the liquid phase changes to gaseous phase at a constant temperature. This constant temperature is called boiling point. We know that boiling point of water is 100 degrees Celsius. This is an example of boiling, right? They will ask compulsory the differences between the evaporation and boiling because they are somewhat similar to each other, but they are not similar, right? Boiling the boiling is a process in which the liquid phase changes to gaseous phase at constant temperature, but evaporation is also a phase that a gaseous liquid phase changes to gaseous phase at any temperature. It is the differences between evaporation and boiling. Boiling of water is 100 degrees Celsius, or it is in Kelvin. How to change it into Kelvin? We want to add 273 to the 100 degrees. 273 plus 100, 373. The 100 degrees Celsius is equal to 373 Kelvin, right? Next, latent heat of vaporization. It is also very important. The heat energy required to change 1 gram of liquid to gas at constant temperature is called latent heat of vaporization. Heat energy required to change 1 gram of liquid to gas at constant temperature is called latent heat of vaporization. L is equal to heat energy by mass. L is equal to heat energy by mass, Q by M. Unit of latent heat in CGS is calorie by grams. The unit in CGS unit of latent heat is calorie by grams, and the SI unit of latent heat is joule by kg. SI unit of latent heat is joule by kg. The CGS unit of latent heat is calorie by grams. Next, the latent heat of vaporization of water is 540 calorie by grams. This is most important bit for 1 mark. Latent heat of vaporization of water is 540 into calorie by grams. Next, melting. What is melting? The process of converting solid into liquid is called melting. The process of converting solid into liquid is called melting. We saw the example that ice cube are taken from refrigerator or kept in a bowl outside the air, then it becomes to liquid. This is called melting. The process of converting solid into liquid is called melting. This is the process of melting. Then next, the constant temperature where ice melts into water is called melting point. We learn about boiling point. This is melting point. The constant temperature where ice melts into water is called melting point. Melting point. Ice melts at 0 degrees Celsius or 273 Kelvin. We study about that. 0 degrees Celsius is equal to 273 Kelvin. Right? Ice melts at 0 degrees Celsius. Note this point. Next, latent heat of fusion. Latent heat of fusion. The heat energy required to convert 1 gram of solid completely into liquid at constant temperature is called latent heat of fusion. The heat energy required to convert 1 gram of solid completely into liquid at constant temperature is called latent heat of fusion. The value of latent heat of fusion of ice is 80 calorie by grams. The latent heat of ice is 80 calorie by grams. Right? Next, last, that is freezing. What is freezing? The process in which a substance in liquid phase changes to solid phase by losing some of its energy is called freezing. It means a liquid body changes to solid body by losing its heat. It is called freezing. The process in which a substance in liquid phase changes to solid phase by losing some its energy is called freezing. The freezing of water takes place at 0 degrees Celsius. Water expands on freezing. Water expands on freezing. Okay, density of ice is less than that of density of water. The density of ice is less than that of density of water. Right? This is about the heat chapter. We have to learn about all this. Okay. These are the very important synopsis or learning outcomes of these lessons. These lesson. Okay. Now I want to say some important questions for you. First question, that is write the differences between evaporation and boiling. This is very important question for 8 marks. The differences between evaporation and boiling. Next important question is explain the procedure to finding specific heat of solid experimentally. Explain the procedure of finding specific heat of solid experimentally. These questions are in our textbook, right? Next, what happens to the water when wet cloths dry? What happens to the water when wet cloths dry? Next question, suggest an experiment to prove that the rate of evaporation of liquid depends on its surface area and vapor already present in surrounding air. Okay, give an example. They said they give an example to prove that the rate of evaporation of liquid depends upon its surface area and humidity already present and water vapor already present in surrounding air. It's also called humidity. Okay. Next important question. Okay, I said now, what role does specific heat play in the keeping of watermelon cool for a long time after removing it from the fridge on a hot day? What role does specific heat play in keeping a watermelon cool for a long time after removing it from fridge on a hot day? Right? These are the important questions of this lesson. Okay, thank you.